Hey, guys, ever wonder what the world's really made of? Not the stuff you see every day like your truck, your morning coffee, or the game on TV, but the tiny, invisible world where things get seriously weird. Welcome to Quantum Mechanics, a story that's part science, part magic, and totally real 100%. Imagine you're shrunk down to the size of an atom, hanging out with particles like electrons and photons. These little guys don't play by the rules you're used to. They're like the rebels of the universe, and they've got some wild tricks up their sleeves. This is where quantum mechanics lives, studying particles like electrons and photons that don't behave like anything in our everyday world. These particles don't follow the rules of classical physics, the kind that governs a rolling ball or a speeding car. Instead, they dance to a stranger tune. In 1900, Max Planck sparked a revolution by suggesting energy doesn't flow smoothly, but comes in tiny packets called quanta. This idea flipped science upside down, opening a door to a new way of understanding reality. Years later, experiments like Thomas Young's double-slit test, first done in 1801 with light, and later in 1961 with electrons by Klaus Janssen, showed something wild. Electrons, which we think of as particles, can act like waves, spreading out and interfering with themselves. It's as if a single pebble thrown into a pond creates ripples that clash and combine. This wave-particle duality shakes the idea of a fixed reality. Nothing is just one thing. A particle can be here, there, or somehow both. Like a dream where the rules keep shifting. It's a world that feels alive, fluid, almost magical. Now things get even weirder. In that double-slit experiment, electrons change their behavior when we watch them. When unobserved, they act like waves, creating patterns of light and shadow. But the moment we measure them, they snap into being particles, as if caught in the act. This hints at something profound. Could our act of observing shape reality itself? Some scientists wonder if consciousness plays a role, suggesting our minds might help mold the world we see. Others, sticking to tradition, say it's just the nature of particles switching between wave and particle states. But if consciousness does influence reality, what does that mean? Are we passive viewers? Or are we somehow part of the cosmic script? The electrons' dance seems to depend on whether we're watching, like a shy performer changing their act under the spotlight. It's a puzzle that makes you question what's real. Is reality out there, solid and unchanging? Or is it woven partly by our gaze? Step back to the early 20th century, where minds like Niels Bohr and Werner Heisenberg reshaped our view of the universe. They crafted the Copenhagen interpretation, a cornerstone of quantum mechanics. It says particles exist in a state of possibility, called superposition, until we measure them. Imagine a coin spinning in the air, neither heads nor tails, but somehow both until it lands. In 1935, Erwin Schrödinger gave us a famous thought experiment. Picture a cat in a box, tied to a quantum event that could leave it alive or dead. Until you open the box. The cat is both, existing in a strange in-between state. It's not just a mind game. It shows how quantum particles live in multiple states until observed. This idea stretches the imagination, suggesting every possibility exists at once, waiting for a single glance to pin it down. It's a universe of endless potential, humming with what could be. But what if every possibility doesn't collapse into one reality? In 1957, Hugh Everett proposed the many worlds theory, a mind-bending idea. He suggested that every quantum event, every measurement, splits the universe into new branches. Each choice, each observation, creates a new world where a different outcome plays out. Imagine countless versions of you, living every possible path. Modern experiments, like those with photons at places like CERN, back up the idea of superposition, showing particles can exist in multiple states, If Everett's right, every decision you make could spin off a new reality. Did you choose tea over coffee this morning? Somewhere, another you chose coffee, living a slightly different life. It's a dizzying thought, one that makes you wonder how many worlds are out there, each one real in its own way. The universe feels less like a single story and more like an infinite library of tales. Quantum mechanics isn't just abstract philosophy. It's behind some of the biggest leaps in our world. In 1947, the transistor was born, a tiny quantum-powered switch that sparked the computer revolution. From there, we got personal computers, smartphones, and even MRI scans that peer inside our bodies. Lasers, another quantum invention, guide everything from surgery to high-speed internet. These technologies stem from understanding how particles behave at the smallest scales. It's wild to think that the strange rules of the quantum world, where particles act like waves and exist in multiple states, lead to tools we use every day. From the screen you're watching to the medical scans saving lives, quantum mechanics is woven into our reality. It's a reminder that even the most bizarre ideas can shape the world in practical, beautiful ways. Even with all these advances, quantum mechanics still holds secrets. The same rules that gave us transistors and lasers don't fully align with our intuition. Particles don't follow straightforward paths. They exist in a haze of probability, defying what we expect from reality. Some scientists argue we're only scratching the surface, using a fraction of what quantum mechanics could teach us. Others wonder if we'll ever fully grasp it. Are we missing a deeper truth about how these particles work? Or are we just learning to harness their strangeness without truly understanding? The technologies we've built are like tools borrowed from a cosmic workshop we don't yet comprehend. It's humbling, exciting, and a little unsettling. If these tiny particles can power our world, what else might they reveal? For now, we use what we know, but the unknown beckons. Let this mystery wrap around you like a soft blanket. Feel the pull of the unknown, and rest in its wonder. Imagine two particles bound together in a way that defies distance. This is quantum entanglement, a phenomenon where the state of one particle instantly affects the other, no matter how far apart they are. Albert Einstein called it spooky action at a distance, puzzled by its strangeness. In 1982, Alain Aspect's experiments with photons separated by kilometers proved it real. When one photon's state was measured, the other changed instantly, as if they shared a secret no space could break. Picture two dancers, light years apart, moving in perfect sync without a signal. It's not just a lab trick. Entanglement hints at a universe where connections run deeper than we can see. Scientists use it today in quantum computing, linking particles to process information in ways regular computers can't. It's as if the universe has a hidden thread, tying things together across vast cosmic reaches. The thought feels like a quiet hum, a reminder that everything might be more connected than we know. Let this idea settle softly. Feel the mystery of a linked universe, and stay curious. Entanglement doesn't just break the rules of space. It challenges time itself. Those entangled particles seem to communicate faster than light, defying Einstein's own theory. But do they really talk, or is something else at play? Some scientists suggest there's a deeper layer of reality, a hidden fabric where distance and time don't matter. Others argue it's just how particles work. No need for mystical explanations, yet the implications are wild. If entanglement links particles across the cosmos, could it connect everything else? Is there a web beneath reality, tying stars to atoms to us? Experiments keep showing entanglement is real, from lab photons to distant galaxies. It's like the universe is whispering secrets we're only starting to hear. What holds these particles together? Could we tap into that connection, glimpse a reality beyond our own? Now picture a particle slipping through a wall. It shouldn't be able to pass. This is quantum tunneling, where particles cross energy barriers that classical physics says are impossible. It's like a fish swimming through a stone wall, effortless and strange. This phenomenon powers the sun, letting particles fuse in its core to keep it shining. Without tunneling, stars wouldn't burn, and we wouldn't exist. It happens because particles don't follow strict paths. They exist in a haze of probability, sometimes popping up on the other side of a barrier as if by magic. Scientists see it in labs, from nuclear reactions to tiny circuits in your phone. It's a reminder that the universe doesn't care about our rules. Tunneling shows reality is more flexible, more surprising than we expect. It's as if the smallest things know tricks we're still learning. Quantum tunneling isn't just a lab curiosity. It's everywhere. In nature, it drives reactions in stars and even helps enzymes in your body work, speeding up life's chemistry. It's like a cosmic shortcut, letting particles bypass obstacles without effort. But could we harness it? Some dream of using tunneling for limitless energy, tapping into its ability to defy barriers. Others caution we don't fully understand it. Is it a quirk of probability, or a sign of deeper rules we haven't cracked? The mystery lingers. Tunneling suggests the universe is built on possibilities, not certainties. If particles can slip through the impossible, what limits us? Could we find ways to push past our own barriers, physical or otherwise? It's a thought that feels both vast and intimate, tying the stars to ourselves. Let it drift through your mind. Marvel at a universe of shortcuts, and stay relaxed. In 1927, Werner Heisenberg revealed a truth that shakes our sense of control. His uncertainty principle says we can't know a particle's position and momentum exactly at the same time. The more precisely we pin down where it is, the less we know about how fast it's moving. It's like trying to catch a firefly in a jar. Grab its location, and its motion blurs. Experiments with electrons and particle accelerators confirm this. The sharper we measure one trait, the fuzzier the other becomes. It's not about bad tools. It's the universe itself, built on a foundation of uncertainty. This principle shapes everything, from the paths of atoms to the glow of stars. Reality isn't a clear picture, but a shifting puzzle, always holding back some of its pieces. It's humbling, almost poetic, to think the cosmos thrives on ambiguity. Heisenberg's principle isn't just for particles. It ripples through everything. From the way stars form to the behavior of molecules in your body, uncertainty is woven into reality's fabric. Some scientists wonder if this fuzziness is just a limit of our measurements, a flaw in our tools. Others believe it's the universe's true nature, a reality that refuses to be fully known. Either way, it changes how we see control. If even particles can't be pinned down, what about our lives? Are our choices, our futures, as certain as we think? Modern experiments keep showing this uncertainty at work. From quantum computers to cosmic observations, it's as if the universe is saying, nothing is set in stone. The thought is both unsettling and freeing, suggesting a world alive with possibility. What does it mean to live in a reality that's never fully certain? Picture this. You're standing in a quiet lab, staring at a device firing tiny particles through two slits onto a screen. This is the double-slit experiment, a cornerstone of quantum mechanics that's been baffling scientists for decades. When you watch those particles, they act like bullets, hitting the screen in neat patterns. But when you look away, they behave like waves, spreading out in strange, rippling interference patterns. It's as if the particles know you're watching. The act of observing changes their behavior. In 1998, researchers at the Weizmann Institute confirmed this with photons, showing that reality shifts when you pay attention. It's not just a lab trick. It suggests your consciousness might play a role in shaping the world. Think about that. The universe, with its stars and galaxies, might be waiting for your gaze to decide what it becomes. Reality feels solid, but it's slippery, bending under the weight of your attention. It's a mystery that makes you wonder what's really out there when no one's looking. Now, let's dive deeper. Does reality need your consciousness to exist? Or is this just how we make sense of it? Some physicists argue that observation is key, that without it, the universe might just be a haze of possibilities. Others say it's all mechanics. No mind required. The mystery grows when you look at experiments with bigger particles, like fullerenes, those soccer ball-shaped molecules. Even they change behavior when observed, hinting that this isn't just about tiny photons. So, here's the big question. If reality depends on an observer, what happens to the universe if no one's there to watch it? Does it vanish, or does it hum along in some undefined state, waiting for a curious mind to give it shape? Now, imagine something wilder. Every choice, every quantum event, might split the universe into countless versions, each playing out a different story. This is the many worlds theory, proposed by Hugh Everett in 1957. Picture a moment where you chose coffee over tea this morning. In one universe, you're sipping that coffee. In another, you're holding a steaming mug of tea, living a slightly different day. Supercomputers in 2019 ran quantum simulations showing that parallel realities could, in theory, exist. Each decision, each particle's path, creates a new branch of reality. It's mind-bending to think about. There could be infinite versions of you out there, each living a life shaped by different choices, different chances. The universe isn't just one story. It's a library of endless tales, all unfolding at once. But here's where it gets tricky. The many worlds theory clashes with the Copenhagen interpretation, which says reality collapses into one state when observed. Neither side has proof to settle the debate. Yet, experiments with photons hint at something strange. Their behavior suggests that these parallel states might brush against each other, like shadows overlapping. Scientists can't yet say if these worlds are real or just a mathematical trick. So, let's ponder this. Is there another you in another universe, wrestling with the same question right now? Are you connected to countless other selves, each living a life you'll never know? The thought is both thrilling and unsettling, a cosmic puzzle that keeps you wondering as you drift towards sleep. Let's shift gears to something even stranger. Time. In quantum mechanics, it's not the steady march you're used to. Particles seem to defy the rules, acting as if they know the future. Take John Wheeler's delayed choice experiment from 1978. Scientists fired photons through a setup where they could choose, after the photon passed, whether to measure it as a particle or a wave. Here's the wild part. The choice made in the present seemed to change the photon's past behavior. It's as if time bends, letting the future reach back and reshape what's already happened. In the quantum world, time flows like a river running backward, twisting in ways that defy your everyday sense of now and then. This oddity isn't just a one-off. Experiments with photons sent across vast distances, even light years, show the same effect. It raises a haunting question. Is time just an illusion? A story we tell ourselves to make sense of the universe? Some physicists think our perception of time comes from how we observe quantum events, not from some fixed cosmic clock. Others argue time is real, but behaves differently at the quantum level. Either way, the mystery lingers. If past and future blur together in the quantum realm, where are we really living? Are we caught in a moment that's both now and not? A fleeting snapshot in a universe where time doesn't play by our rules? Let that thought settle as you close your eyes tonight. Picture a quiet night, stars twinkling above, and a machine humming with the power to rewrite what's possible. Quantum computers use qubits, tiny bits of matter that exist in multiple states at once. Thanks to superposition and entanglement, they don't just process data, They leap beyond anything your old computer could dream of. In 2019, Google's Sycamore solved a problem in 200 seconds. A task that would take a supercomputer 10,000 years. That's not just speed. It's a revolution. These machines tap into the strange rules of quantum mechanics, where particles can be here and there, yes and no, all at once. It's like stepping through a door to worlds we've never seen, where calculations that once took lifetimes finish in a heartbeat. As you settle in tonight, think of a future where quantum computers unravel mysteries we can't yet grasp. Now, what can these machines do? They could model complex molecules, paving the way for new drugs or materials stronger than steel. The potential is vast. But here's the puzzle. Could a quantum computer unlock the nature of reality itself? Some physicists believe it might map the universe's deepest secrets, while others argue it's just a tool, not a cosmic key. The debate hums with energy, as experiments push boundaries we thought untouchable. Quantum computers tackle problems that once seemed impossible, hinting at answers just out of reach. So, as you drift toward sleep, ponder this question. If a quantum computer could decode the universe, what would it reveal about who we are? Would we see ourselves in its calculations, or something entirely unknown? Picture a world where secrets are locked tighter than any vault, guarded not by steel but by the laws of the universe. Quantum cryptography uses entanglement, where two particles are linked, so a change to one instantly alters the other, no matter how far apart. In 2017, China's Mixia satellite sent secure data over 200 kilometers, proving the power of this technology. It's not just a code, it's a whisper between stars, protected by physics itself. No hacker, no matter how clever, can break a lock tied to the quantum world. This is a shield for our digital age, keeping everything from bank accounts to global secrets safe with a strength that feels almost otherworldly. But every breakthrough has a shadow. Quantum cryptography could secure our world like never before. Yet it raises questions. If these codes are unbreakable, what happens if they're wielded by the wrong hands? Could a rogue group hide their plans, untouchable by any authority? Experiments show both promise and risk, as entangled particles behave in ways we can't fully predict. Some say this could bring peace, locking away sensitive data forever. Others warn it might spark new conflicts, with secrets too deep to uncover. As you close your eyes, let this question linger. Will quantum cryptography bring safety? Or will it ignite a new kind of war, fought in the unseen realm of particles? Picture a moment where you send something across the world, not by wire or mail, but instantly, like a thought leaping from your mind to a distant shore. Quantum teleportation transmits a particle's state from one place to another without moving the particle itself. In 2014, Delft University scientists teleported a qubit state across 300 meters, a feat that feels like magic but rests on solid physics. It's not about beaming objects like in old sci-fi shows. It's about copying a particle's essence and recreating it elsewhere, perfect and untouched. In a flash, it's as if you sent a piece of your soul to the stars, and it arrived in an instant. The possibilities are thrilling, but the mystery runs deeper. Quantum teleportation could build an internet of pure light, a network where data flows instantly across the globe. Experiments hint we're close, with photons carrying information in ways we barely understand. But here's the big question. Could this technology ever carry more than data? Could it transmit something like consciousness? Or is it limited to lifeless information? Some dream of a future where thoughts themselves could leap across space, while others say we're far from such a leap. The debate pulses with possibility, as each test brings us closer to a connected world we can't yet fathom. So, as sleep pulls you in, let this question drift with you. If we could teleport our thoughts, what would reality become? Would it still feel like the world we know? Or something far stranger? Stars glow above, hiding secrets of the universe. Quantum mechanics shows reality isn't fixed. Tiny particles exist as energy, only taking shape when measured. Matter is just vibrations in a web of possibilities. You don't just see the world. Your observation shapes it, blending you into the system. Watching isn't passive. It's a force that molds existence. This truth grows with entanglement, where particles far apart act as one. The universe is a connected web, not separate pieces. Randomness rules, not rigid plans, breaking old ideas of a predictable world. If particles are linked, so are we. Your choices ripple, touching lives and stars. As sleep nears, ponder this. How separate are we in a universe woven as one? Night falls, and quantum mechanics offers wisdom. Our knowledge is a sketch, never complete. The universe is vast, urging humility and openness. Reality shifts with how we look. Showing truth has layers. In a world of rigid answers, this calls for flexible thinking. Seeing beyond right or wrong, entanglement reveals a deeper truth. Everything is connected. Your words, your actions, send waves through a cosmic web. You're not alone, but part of a vast network. As you drift off, ask this: what waves will your life send into the universe? In the quiet night, quantum mechanics reveals a new view. Reality isn't fixed. It's a web of possibilities, shaped by your gaze. Knowledge is part of truth, not its mirror. From particles to thoughts, all is linked by strange, beautiful law. As you sleep, consider this. You help shape reality. What world will your choices create? Thank you for joining us tonight to explore the mysteries of quantum mechanics. Share your thoughts on this strange reality in the comments below. If you enjoyed this cosmic exploration, please like the video and subscribe. Your support will help us create more stories on your sleep science journey.